Hi, everyone. Me and Katie are here today to share with you the best of both worlds with Kotlin and functional programming. We're super excited to be here. We're going to go through our presentation and then leave some time for questions and give you some resources to keep learning after this talk. So yeah, we're going to get started. So I'm Shelby, and I'm a software engineer, and I'm currently working at Twitter, and I live in Boston, Massachusetts. I'm working on the search infrastructure team, so lots of backend work. I'm not using Kotlin right now, but I'm using Scala and Java.
And I'm Katie Levy. I'm a software engineer at Amazon, working in Amazon Fashion in New York City. We kind of use a bunch of different languages, but we're really excited to be here today. So here's kind of what we're going to go through. First of all, what even is functional programming and why is it important? Why do we care about it? Secondly, how to make your Kotlin code more functional, as well as functional programming examples with Arrow, which is a functional programming library for Kotlin. And lastly, we'll give you some resources to learn even more on your own.
So why are we talking about functional programming? Well, Katie and I found that Kotlin is a really awesome language to teach and learn functional programming. So some specific aspects that we found Kotlin helped teach were treating your code like a mathematical equation. So with the same input, you always have the same output, composing smaller functions into larger functions, avoiding shared state, mutable data, and side effects. Functional programming is really good for multi-threaded support. So for Android specifically, this is really helpful and necessary. And then the more immutable data you have, the easier it is to test. So there's lots of different ways we can keep describing functional programming, and it can be very daunting and overwhelming at first, but we're going to just break it down for you today so you can get started using functional programming in a practical way.
So the first concept we want to talk about is pure functions. And on the left, we kind of see a pure function that has an input and an output. And for the same input, every single time, you will get the same output. And with a pure function, you don't have any sort of side effects or mutation to shared state. You just have input, operation, output. So this is very much like a mathematical equation, like Shelby was saying. And it kind of functional programming in general depends on these pure functions. And on the right, we have something with arbitrary side effects going on in the middle. That's what we don't want. We want to have something input, output, very simple. So this is kind of foundation that functional programming is built off of.
So why do we want to use any of these functional programming concepts? There's no shared state, like we said, so multi-threaded programming you could do without race conditions, and you can avoid memory leaks when using multiple threads. It's also easier to test and debug because you're not referencing external variables, which would be side effects. So it makes testing very straightforward because everything you are sending in through the parameters. So all you need in your function is your input, and then you're not worrying about any external factors. You also can maintain your code easier because the logic is very isolated. So adding and removing features should be very easy. And also adding and removing tests should be very easy because all of that logic is isolated.
So all of these were great benefits, but why Kotlin? Why did we pick functional programming with Kotlin? We've found that functional programming is really encouraged through the Kotlin programming language. It's almost like when the language was being developed, they wanted you to develop in a functional way. And it is also possible to do object-oriented programming with Kotlin as well. So it's important to note Kotlin isn't a fully functional programming language like a program like language like Haskell is, but it can encourage you to, and you can kind of mix a little bit in. If you're migrating your application to a more functional programming style, you can do it with Kotlin and not make a huge jump from using a different language. So at the end of the day, both Kotlin and functional programming have these sort of core principles to have concise code, to have it be safe. And at the end of the day, that gives you higher quality applications and increased developer productivity. So we'll walk through with you guys how to do functional programming with Kotlin, what it might look like.
So how can you make your code more functional using Kotlin? We're going to dive into more examples with all these things, but we wanted to tell you overall some quick ways if you're already familiar with built-in functions on collections. So map, flat map, and filter. Immutable variables in Kotlin, easily defined with val. Pure functions, so having no side effects. Single expression functions, so you can compose a lot of functions together.
It's important that in Kotlin, functions are first-class citizens. That means that functions can be stored as variables, they can be used as arguments to functions, and they can be returned from functions. So Kotlin has the ability to do a lot with functions, which is great for functional programming. There's also a lot of cool functional programming pieces tied into the language itself, like a lot of the Kotlin collections having functions already there for you to use, like map, filter, fold, flat map, that encourage you to do function chaining and to have sort of the input output sort of concept of mathematical equation, tying it all together.
So let's dive into the code and go over map to start. So if you're familiar with Java, this is Java on the left. We have a function +5 that has a list of integers called number list, which is an array. And then we are using number list dot stream and then dot map to add 5 to every number in the list. And then at the end, we have to do dot collect and then use that collectors dot toList. So then if you look at the Kotlin side, you'll see that it's a lot simpler, more concise and fluent. We can define a list with list of 1, 2, 3, 4. And then when we map, we don't need that dot stream or dot collect. We can just do number list dot map. And then we can use a keyword it to represent every number in the list instead of defining a new variable. Similarly, filter has the dot stream and dot collect at the end. In Java, we're saying we want to keep any number in the list that's greater than 2. And then on the right in Kotlin, we can use that same keyword it to define what we want to filter.
So here's some Java code that goes through and it finds the greatest city. In this case, Shelby lives in Boston, so we're using Boston as the greatest city. But you can see how you create a list of all these cities, then you iterate through all of the cities and find the one that equals Boston, and then add it to a new list and return that list back. So we're going to kind of show what it might look like in Kotlin in a functional way. If anyone wants to guess in the chat how many lines of code this would be in Kotlin in a functional programming manner. Okay, we got a 2, we got a 1, we got a 3, 2. Okay, let's see what it is.
So we can actually do this in one line, which we don't always advise everyone to try to get their code to one line. We know probably everyone in this group likes to do that and it's fun to do. But in this case, it's cool because we can use that list of and define the list right there with San Diego, Boston, and Seattle. we're using a single expression function here to have fun greatest cities equal to our function body without that return keyword. And then we're using dot filter, which we just talked about, with the keyword being it, to say filter if that string in the list is equal to Boston. So it's really easy in Kotlin, we found, to chain things together like this. But even so, if it gets bigger and bigger, you can break them out into their own single expression functions. And so it reads a lot more fluently like English. And it's a lot simpler than Java, we think.
Yeah, so another example is flat map. And here we have kind of a way to flatten objects inside of an object. So we have two lists of integers inside a list of lists. And it can sound kind of confusing, but just think of like one list with two lists inside, and those two lists have integers. So in Java, you can see what it looks like on the right, on the left, and Kotlin on the right. We're sort of flattening the list together, so we end up with one list of integers and then adding 5 to each of those integers. It's also important to note here we have for Kotlin inline operators. So we have the list plus 5, and you're actually like we're actually doing 5 plus the whole list, which actually will add 5 to every integer inside the list, which is a cool little thing with Kotlin that you can't necessarily do with Java. So it concises everything together, makes it a lot easier to read and see what you're doing. And then this allows you to use kind of objects that are wrapping other objects, and taking advantage of different types.
So another way you can make your code more immutable is by using val instead of var. If you define variables with val, you cannot mutate it. And if you try to mutate it, shown here with this variable, immutable variable, it will be a compilation error instead of a runtime error, which is really helpful when you're trying to debug your code. You can also define variables with var if you want to mutate it, but we don't recommend that.
And similarly with collections, by default, collections are immutable. So list of creates an immutable list, and the developer has to explicitly type out mutable list of if they want a mutable list. So it's another way that we think Kotlin was built out to be in a functional programming style by encouraging immutability with your objects you create.
So another way Kotlin helps encourage functional programming is by expressions, not statements. So Kotlin has a lot of different things that would be statements in Java, but are expressions in Kotlin. But one of them is the when expression. And so here we're using a single expression function where we have function foo with an integer sent in. The return type is string, and we're setting it equal to when. And then at every logic check, we're returning a string. And because we have that return type defined, if we changed any of those types to something else, we would get a compilation error. And also this just encourages immutability because we're returning right away from this when. And so we're not having a bunch of logic checks with blocks and then mutating some variable and then returning the variable at the end. This just encourages you to be explicit with what you're doing and what you're returning. And there's no need to set any temporary variables here.
So you also have single expression functions, as we kind of saw with the greatest cities function. So all of your block body is just in the expression. So you just have the equal sign, whatever you're doing. It could be, one line of logic, or it could just, in this case, you probably would have a variable or something, but you just have it in one line of code, which looks exactly like a function, mathematical function. And this kind of encourages you to build up larger functions composed of smaller functions, which is a concept we were kind of describing earlier with functional programming. So you can have these small functions, make your code very readable, very easy to understand what you're doing without having all the block body extra space in that class. So it's very easy to compose things together and make it a huge mathematical equation of smaller ones. So just to recap, we went through built-in functions on collections. That would be with map, flat map, filter. We had immutable variables by using val and using the immutable like collections like list of instead of mutable list of. We have pure functions with no side effects and no shared state being mutated. And we also have single expression functions to compose together into larger functions.
Okay, so now that we went over how to be functional using just Kotlin, we're going to dive a little deeper, and we're going to talk about Arrow, which is a functional companion to Kotlin's standard library. And Katie and I started using Arrow once we felt comfortable using Kotlin and starting to do functional programming in Kotlin. And we found that it continued to solve more of our problems that we were having in Java. So some abstractions over Kotlin libraries that Arrow provides are option, either IO, functor, applicative, and monad.
So all of those things might sound kind of scary and mathy and functional programming, but there's a lot you can do with Arrow, and it all comes down to just the main purpose that they have stated on their website. Arrow empowers users to write pure functional programming apps and libraries built atop higher order abstractions. So it's not necessarily necessary to bring Arrow into your application. And like Shelby said, we started using it more once we were comfortable with Kotlin and some of the functional programming concepts inside of the language itself. Then we started to go even farther and bring Arrow in to use some amazing tools to make things even more functional programming styled.
So like Katie said, it can be a little daunting, but we didn't add all of those abstractions to our projects at once. We focused on one at a time, and the first one we focused on was either. So we're going to jump into the code and explain what it is and show you some examples. And either is really just a sealed class in Kotlin. And so it has a right and a left. And so you'll see here, if we define either, if we define val right with the return with the type either with the string on the left and then integer on the right, we can say either dot right and then send in an integer. But then if below we do either dot left, we send in a string. So it's really the right is the success case and the left is the error case. So we can also use those map and flat map methods that we talked about earlier. But it's important to note that when you do that, it's only going to operate on the success values, their right biased functions. So if we do right dot flat map and then we wrap either dot right with it plus 1, it's going to operate on that 5 that's defined in the either dot right. But if we try to map or flat map on an either dot left, it's just not going to do anything. So this can be really helpful, and we'll show you some more examples, but it's helpful if you are chaining a bunch of things together and you only want to operate on the success case. This is really good for like exiting that chain in a simple way.
So with functional programming, exceptions are not great. They sort of add side effects to your program and the program's flow. So we prefer to use typed errors like the either type and have that represent our error cases in a more functional programming manner. So here we can walk through some examples of how we might use the either type rather than throwing an exception. So we have here a function that parses a string into an int, calculates a reciprocal, and then converts it to a string. So you can see that there are some error cases that we want to handle, and normally we throw the exception, like parsing and it's not parsable to an int, or getting a reciprocal, but it's 0. You can't really do that. So this is what it might look like with exceptions. And then we'll show with what it might look like with the either type. So here we have, we're parsing, this is the same sort of function as before, but we're returning the either type, wrapping the number format exception. And that exception is the left side of either, and the success case is the right side of either, which is the int. So we're going to ask you all if you could guess what the return type of this might look like, where we're parsing not a number. What would we get back from the parse function? We'll give you a minute to think and put your answers in the chat. To make it easier, we're just gonna ask if is parse not a number an either left or an either right? Yeah, either left. That's correct. So left is the error case. So we'll be, if we pass this in, not a number to the parse function, we'll be getting back left with inside of the left wrapped number format exception. So how about for the next one, if we parse 2, will we get an either left or an either right? Yeah, we would get a right. So right is the success case, and we would get the either right type with 2 inside of it. Okay, to make things a little bit more complex, this is the other functions we were looking at: reciprocal, stringify, and magic, tying them all together. So magic will parse a string using that function we were just looking at. It will flat map. Remember, map and flat map are for the success case, the right hand side of either. And we'll get the reciprocal of the value. And then with map, we'll stringify it into a string again. So we have magic of 0 passed in. And if you remember from before, you can't take the reciprocal of 0. So can anyone guess this would be either left, either right, what it might look like? Yeah, it would be either left. Yeah, a left with illegal argument exception cannot take the reciprocal of 0. Okay, cool. So what about if we do magic of 1? Yeah, we'll get either right. Yeah, a right with the 1 value inside of it. And that will be wrapped inside the either dot right type. And then not a number. What will we get for that? Yep, left again. So this will be the error case again. It will be a different exception. So the first one was the illegal argument exception, whereas this one is number format exception, because we can't parse it into an int. So you can see here that the left error case encapsulates what the specific error is by holding the exception type. Cool. So adding on to this example, we can call that magic function that will, parse it, take the reciprocal, then stringify it, and then evaluate what the result is with a when expression. And with the when expression, we can operate on the return type as being either an either left or an either right. And when it's an either left, we can then operate again with a when expression on which exception type it is to return a final result. So in this case, we see if it's an either dot left, the error case. If it is, we get the value inside, which is x dot a. If that's number format exception, we know it's not a number. If it's an illegal argument exception, can't take the reciprocal, otherwise some other unknown exception. And then we know if the either right is we got the reciprocal, and this is what the reciprocal value is. And this means we don't have to throw any exceptions. We can just have the error case encapsulated inside of the type to represent an error and a success case.
So now that you're more familiar with the either type, we wanted to show some examples of code that really could utilize the either type and then show how to transform it to start using it. So this is a function called services in Java, and we have an int status variable defined. And then within the try, we're calling some service, getting the response, checking the status code. And then if it's a 200, we're going to call the next service. And then if that service is a 200 or 201, we're going to call a third service. So there's lots of mutation going on here. There's lots of defining what a success case is by checking the status code. This can get very messy. And if anyone's worked in a Java service before, I'm sure you've seen something like this. Throughout the code, it's really hard to figure out, what is a success case from one service versus another service. And then here we have catching the exception, and then this is just a general exception, and then we're returning some error code. So we can start improving this by first writing the call for service method that returns an either type instead of just an integer. So we have an either with the string as the left and then an integer as the right. We have val status equal to 200. We just have this hard coded right now to just show the example, but that would be calling some external service. And then we return when the status is 200 or 201, the status wrapped in an either dot right. And the status could be something else. Then it could be a data class or something that has more information than just the status code. But right now, it's just an integer wrapped in a right. And then if it's an error, we just wrap the string error in an either dot left. So then if we go and rewrite the call services method, we're going to use that call for service function that we just wrote. And then we're going to check if it's an either dot right type with the smart casting in Kotlin. We're going to check if it's either dot left also for an error case, and then use that response dot a to get the actual response message from the either. And this is nice because we're defining the success state at the lowest level of the code. And so anywhere else we're going to use that response from call for service, we're going to know if it's a success or error based on the type. And we're not going to be doing any of those if statements, and there's going to be less, hopefully less mutation in the code throughout. So this is just some of the benefits that we have seen from what we just went over. The status checks are at the lowest layer of the code. We're going to handle errors with types rather than exceptions, which also help when you're debugging or handling any issues in your code. And then we're also going to avoid mutation, which also makes it really hard to figure out if there's some sort of bug or issue that happens where it happened, since there was mutation. And now we can avoid that completely using either.
So here are some resources to learn even more. You can listen to our episode on the Lambda Show podcast. We talk about some of these concepts more in depth, more philosophically. And there's also the two books, Functional Programming in Java, Functional Programming in Kotlin, that are great resources. The Kotlin one is pretty new, but definitely shows you some more real world examples of how you can change your code into a more functional programming style.
Yeah, so thank you so much, everyone. Definitely reach out to us on Twitter. We'll be here to answer some questions now, but if you think of anything else, definitely tweet us or send us a message. We love to hear how everyone here is using functional programming in their code today, or if they have any opinions on if we should use it more in industry or not. We'd love to keep the conversation going.
Awesome. Thank you very much. We do have a question in the comments about, it looks like we can replace all sealed classes with either. Is that true?
So that's not necessarily true. There's different cases for having a sealed class, and this would be a case if you might just have a success and an error. You could use the either type to represent that, but you can also use sealed classes to represent more than just two variations. So an example might be if you are loading a screen, if you have just a Android application with a screen, you could have a sealed class of the screen, like what the represents, a loading and an error. So you would have those three states, and if it was a success, it's good. If it's loading, you want to show the loading part. If it's an error, you want to show the error. And you can store the different values that you need inside that sealed class, since they could have different sort of values inside of them to represent what that screen might look like. So there's different use cases for sealed classes, and it's nice that you can kind of have a multitude of different variations of a sealed class, but then use the when expression to have those different options explicitly defined. But yeah, if you need a success and an error, the either type is a great use case for that.
Awesome. So from my perspective, how do you get started when you've got a big code base? And I mean, do you throw arrow in there straight away, or do you recommend just kind of going the journey that you showed us here with the kind of classic Kotlin kind of base functionality onto arrow, or when would you introduce arrow? It seems quite a big thing to have to sort out in your head.
Yeah, so I think with any new technology, it's good to go slow and incrementally, especially when you have a big team of people who have never used that technology before. So not just with functional programming, but we think this for any technology you're using. And when you talk about functional programming, not everyone knows what it is, and there's a lot of misconceptions. And so you don't want to overwhelm anyone and just turn them off to the whole idea completely. So that's why we've used some of the things like map and flat map, starting small, changing your for loops and if statements to map and filter, just in little parts of the code, and helping people get started, and then teaching them that is functional programming. So definitely don't introduce arrow right away, because you want people to get familiar with the concepts. And then once you feel like everyone's on board and everyone's kind of slowly making the code more and more functional, then we think it would be great to introduce arrow. But the same way, don't introduce everything that arrow provides right away. Make sure that you're introducing something that everyone on the team can review the code, and be a part of it, instead of just having a bunch of code in your code base that no one understands but you. That's a really bad state to get in. So we want to avoid that by going slow and bringing the team along.
Yeah, and just to add to that, what we've done on teams in the past is, if something new, like a new concept is being brought in, or a new type is being brought in from Arrow, whoever's bringing it in kind of gives a quick presentation, just to explain what it is, so people can understand it as they're doing the code review. Or even we've done like group coding before, of trying out a new feature so everyone can kind of learn it, rather than a few people being, domain experts on it and everyone else not being able to review the code. It's really important that everyone's educated on the feature and, like Shelby said, do it kind of slowly and incrementally.
Cool. So do you think that's the benefit of Kotlin in this scenario then, rather than just a pure functional language? You get, like the title of your talk, the best of both worlds. Is that kind of where you guys are with that?
Yeah, we think so. I mean, it just seems like some of the ways we've introduced it, there's just less boilerplate code. It's more straightforward, and we think Kotlin is easy to read and learn because it's similar to a lot of different languages, and it kind of pulls the best features from a lot of different languages. So I think it's great for someone new learning to code in general or learning functional.
Excellent. Got one more question in the comments. I think Lee asked this, but do you think languages like Kotlin helps introduce functional programming?
Yeah, definitely. Especially with things like the flat map filter that we were showing, the mutability, it just kind of encourages you to program in a more functional programming style. And so if you're trying to use the Kotlin language correctly, you end up kind of doing a functional programming style of things. It is kind of a mind shift change to go into a functional programming style, and it can take some time for people to get comfortable with it. But we found that introducing both at the same time ends up being okay. Functional programming, like smaller things like map, filter, flat map, immutable variables with Kotlin, people kind of learn both together, and it's a lot easier to do in a language like Kotlin rather than something like Java.
Excellent. Okay, I think that's it on the questions. Big thank you to John, Shelby, and Katie for giving up their time. It makes running these kind of meetups a dream, to be honest with you. So I appreciate your time.